Yeah, welcome to Wake Energy and Power. Remember to pause and then go through the problem, answer the problem on your own, and then from there you can check if you answered in the correct way. So Wake Energy and Power state the principle of conservation of mechanical energy, and then that's the definition. The total mechanical energy in an isolated system is conserved, meaning that it doesn't change. So make sure that you have those words that are ticked or equivalent ones. So now we're going to answer number 2, 5.2, determine the speed of the block at that point. So that is at point Q, and then we're going to go through the information that's from P to Q, follow those dots. So that's the space, the distance required to travel, and then you analyze everything. You check that your VI there, 0 for stationary, and then you have V final there that you need to calculate. So what is needed is that you need to have the correct equation, because the equation is there. So you need to know that mechanical energy initial is equals to mechanical energy final. So with that in mind, then you can go on and solve the problem. So that's how it works. So mechanical energy comprises of kinetic energy and potential energy, which is stored energy. And then with all that information, so that is, remember, it's the mechanical energy initial final, so which means kinetic energy plus potential energy before is equals to kinetic energy plus potential energy final. So we go there, we check what our initial kinetic energy will be. So our kinetic energy there initial will be 0 because it wasn't moving. Because remember that kinetic energy has to do with movement. So if its object is not moving, then there is no mechanical energy. So potential energy is mg height. So mg will remain the same. The difference will be that you have heights that are different. So in this case, you can see that there was no kinetic energy, you only had potential energy. But as you move to point Q, you have both potential and kinetic. So you can see that initially we only had potential energy, but finally we have kinetic and potential energy. So as we check in there, height, initial and final, and then height 2 there. So we divide by masses, because they all have masses on both sides. So we cancel that out, and then that gives us 2. That is G, which is 9.8. Coming back to the height there would be 3 meter. So that would be 3 meter height, and then you have, because remember the mass cancelled out, so now we have on the other side speed, which is speed final, and that's what we want to calculate. And then plus you have 9.8, and then our height there is height from the ground is 1.25. So when looking at height, it's always from the ground, so remember that from the ground 1.25. So with 1.25 you get to calculate there, solving for V final. So we're going to have that equation there, V final, because making that a subject of our formula. So you got half there, which is in this case it's going to be 29.4 that, and then on that one there is going to be 12.25. so that is for that other part, because remember that one moves on the other side. So V final squared will be 17.15. So that is our answer, and then have that, multiply that by 2 over 1 to give us 3, 4, 3. Okay, then v will be square root. So we have v there, it's going to be plus or minus square root of 34.3. So that gives us an answer of 5.86 meter per second. So that's our final answer. And then yeah, so that's our answer. So that's it. So you must remember here conservation of energy, which is conservation of mechanical energy in this case. So we're going to put the information. So remember that when you have information, you fill it up on the problem so that you're able to analyze. Like in this case, we know our v final there will be 5.86. And then we come on to the next problem. So the next problem is 5.32, which is required to draw free body diagram of that as it moves from point P to Q, somewhere there. Alright, so let us look at our free body diagram from Q to R. Okay, the point Q to R, and then we're going to look at what we have. So we usually have weight. So weight there, we start with it. So the weight points in that direction into all the problems in free body diagram. So at least you must get 1 mark for every diagram, because you know that the weight will always put down. So we're going to look at the friction there, which is F, and then we have FG parallel there, you have weight, and then you have normal force, you have friction because it's going down, that's weight, that is FG, which is parallel, and then you have the frictional force there. So 5 point there, that is that, but you can also include normal force. So that is normal force there, and then you also have FG perpendicular. So FG perpendicular. So FG, you have FG perpendicular, you have a weight itself, which is FG, you have FG parallel. So there are 3 possibilities of FG. So even if you say FG perpendicular, FG itself, which is pointing down, or you just say FG parallel, so that's also other possibility. Remember, it's 3 marks, so you need 3 forces that are not the same, you know. So you've got friction there, you have normal force there, and you have FG parallel. Yeah, so for 3 marks you've ended. So you get 1 mark for that, 1 mark for that, 1 mark for that. So that's it. So all of these 3 gives you 1 mark, right? But I like using FG parallel because that's the one that helps me solve the weight related part. And then yeah, as you can see now, 5.3.3 use the conservation energy. That's the problem. You must always remember to pause there. The constant velocity. So when you have change in velocity, there will be 0 for constant, because remember final and initial is the same. So when they subtract the final minus initial, to give you 0 if they is the same. So weight of non-conservative force is equals to change, gotta be change in supposed to be change in kinetic energy. So that's change in kinetic energy. Struggling to write the delta there, you know. So change in kinetic energy, yeah, so that change in kinetic energy plus change in potential energy. So that's non-conservative force. So non-conservative force, we look at a component. Non-conservative there is friction. So work done by friction, remember that work is force times change in distance, and then multiply that by cos theta. So cos, because it's opposite, I think it's gonna be 180 degrees. Remember, cos 180 degrees is -1. So that shows you that the force, work done by the force, is on the opposite direction. Then constant velocity there, so remember that it's going to be 0 for kinetic. And then change in potential energy there is going to be mg, that is height initial was 0, but that was height initial there, final was 0 because it's on the ground. So final is 0, and then initial height will be from the ground to point Q is 1.25. So when using height, always use from the ground. The ground is the reference point. So we have there height is 1.25. Okay, so from there now we have to value of x, so we need to find the change in x there. So we have friction there, change on your data given is 50 newtons, and then change in x, that's what we want, and that's going to give us -1 equals, and then you have mass there. Our mass is going to be, we check the mass there, is 4 kg. So our mass is 4 kg, and then we move on and we put the 4, and then g values 9.8 gravitational force acceleration, and then we have -1.25, that is the change there. And then we check in, just do your maths there, find that equivalence, which is going to be 4, 9, and then you have this side -15, and then from there you have change in x. Yeah, so change in x will be, as you can see, it's gonna be change in x. That's exactly what we are looking for. That is going to be -49 divided by -15. So it's equivalent, almost 3 point something. You can check 3 times 6 45. It's gonna be 3.267. So that's equivalent to 3.27. Yeah, and that is going to be our meter done there. So that's 5.3.3. Our next question is the angle between the inclination there. So that is, let's go in the scratcher. They want to find that angle there. So you're going to look at the component, like what component you're going to use to find that. So it's the angle between that. As it increases, will it increase or decrease? Go through the problem, and then that is for the angle between the inclination and whether it's now increased. How will this increase affect the coefficient of kinetic frictional force? It stays the same, doesn't, because remember, stays or remains the same because the coefficient of kinetic friction does not rely on the inclination. It depends inclination of angle, but on the material type, so on the nature of the material. Yeah, so that is it. So you should also know that and bear that in mind. Alright, so between the object and the surface. So the surface, what material is it made of, and the object, what material is it made of. So the relationship between the two is what creates the coefficient of the kinetic friction or static friction. So that's it. Now, as you can see, we're going to go through. That. So now, what we're gonna do, these are homework. So homework question, please go through the question, decrease mass and work energy and power, and then they draw free body diagram there, calculate the network, follow through all the procedures, and then answer the question. So this question is much more related to what we did, but you have to apply, use your knowledge and everything of course. So use energy principle there, find the speed. Otherwise, good luck. If you have any question, please leave comments below, and I'll definitely come back to you. All the best.